In this video, we will discuss about limits of polynomial function. Consider a polynomial function f of x equals a0 plus a1x plus a2x to the power 2 plus etc. up to an x to the power n. Now in this function, put x is equal to a, this f of x becomes f of a. We write a instead of x, we get f of a. F of a equals a0 plus a0 is a constant, so write directly a0 plus a1 into x becomes a1 into a plus a2 into x to the power 2 becomes a2 a square plus etc. up to an x to the power n becomes an a to the power n. We call it as this equation number 1. We know that limit x approaching to a x equal to a. The meaning of this is that as this is not giving you the 0 by 0 form, we directly substitute the value of x. If we directly substitute the value at x approaching to a, so we directly substitute a instead of x, we didn't get 0 by 0 form. So a is the value. Using this, we find the limits of x square, x cube, etc. up to x raised to n. Limit x approaching to a x square equals limit x approaching to a x square, we write it as x into x. X into x is x square. X into x means x raised to 1 into x raised to 1. X raised to 1 into x raised to 1, how we write? A raised to m into a raised to n equals a raised to m plus n. So, here we write it as x raised to 1 into x raised to 1. We write it as x raised to 1 plus 1. That is equal to x square. So, x square can be written as x into x. Here we apply algebra of limits. That is the multiplication of limit. The limits of the product of two functions is equal to the limit product of the limit of the function. So, we write this as limit x approaching to a x into limit x approaching to a x. We know that what is limit x approaching to a x? That is a. What is this? This is also a. A into a is x square, a square. So limit x approaching to a x square equals a square. Is it clear? Similarly, limit x approaching to a x cube equals limit x approaching to a x cube can be written as x into x into x. Here also we apply algebra of limits. Apply the limits separately and then multiply. Limit x approaching to a x into limit x approaching to a x into limit x approaching to a x. What is this? A. This is also a. So a into a that equal to a cube. So limit x approaching to a x to the power 3 equals a to the power 3. Like this way we can find the last value limit x approaching to a x to the power n equals limit x approaching to a x to the power n can be written as x into etc. up to x. How many times? N times. X square we write it as x into x. How many times? 2 times. X cube we write it as x into x into x. How many times? 3 times. Like x raised to n is equal to x into we multiply n times. So limit x approaching to a x into limit x approaching to a x into etc. limit x approaching to a x n times. N times we multiply. So what is x? Limit x approaching to x? A. A into etc. into a n times. A into a is a square. A into a is a cube. A into a etc. into a n times means a raised to n. So we get limit x approaching to a x raised to n equals a raised to n. So limit x approaching to a x is a. Limit x approaching to a x square equal to a square, etc. Limit x approaching to a x raised to n equals a raised to n. Is it clear? In the beginning, we have one polynomial function f of x equals a0 plus a1x plus a2x to the power 2 plus etc. plus an x to the power n. We apply limit on both sides. Limit x approaching to a, f of x equals limit x approaching to a0 plus a1x plus etc. plus an x to the power n. Now here we apply algebra of limits. Apply the limits separately. So limit x approaching to a0 plus limit x approaching to a1x plus etc. plus limit x approaching to an x raised to n. Here limit x approaching to a0. What is the value? Here a0 is a constant. So we write directly, no need of applying the limit. Is it clear? This a0 is a constant. So we write a0 directly, no need of applying the limit. Plus, what is limit x approaching to a1x? We know that a1 is a constant. So we have to take it outside. A1 is a constant, A1 is a constant, so we have to take it outside. So it becomes A1 into limit x approaching to a x. We know that limit x approaching to x is a. So A1 into limit x approaching to a x becomes a. Similarly, limit x approaching to an x raised to n is a constant, so we have to take it outside. An into limit x approaching to x raised to n becomes an into a raised to n. From the previous equation, we write it as a0 plus a1a plus a2a square plus etc. an a raised to n. So this is nothing but our f of x. Is it clear? What this is f of x. Then what is f of a here? A0 plus a1a plus a2a square plus etc. plus an a raised to n. So instead of this, we write it as f of a. Limit x approaching to a, f of x equal to lim. So f of x equal to f of a. Is it clear? Both of the answers are same. If we apply the limit separately, or instead of x, we write it a. Both of the answers are same. Limit x approaching to f of x equal to f of a. Is it clear? Limit x approaching to a, f of x equals f of a. Now observe the above equation and equation number 1. Equation number 1 is f of a equals a0 plus a1a plus etc. plus an a raised to a. This is equation number 1. A limit x approaching to a, f of x equals f of a. Compare these two equations. Observe these two equations. Whenever we apply the limit to a polynomial function, then we get same answer. In the same way, whenever we put the particular value directly, then also we will get the same answer. And both of these answers are same. Or if we substitute the value directly to the function, or if we find the limit of that function, then we get the same answer. This is our final conclusion. So clear? Both of the answers are same. If we apply the limit, these two answers are same. Now let's understand this in detail by taking an example. We know that limit x approaching to a, f of x equals f of a. Here a polynomial function is given x approaching to 1, x to the power 3 minus x to the power 2 plus 1. Substitute the value directly. So x cube becomes 1 cube minus 1 x square, 1 square plus 1 plus 1. That is equal to 1 cube is 1 square is 1, then 1 minus 1 plus 1. These 1 plus 1 and minus 1 get cancelled. 1 is the answer. Here, substitute the value directly, not giving to get 0 by 0 form. So we can do direct substitution. So limit x approaching to 1, x cube minus x square plus 1. That is equal to 1. What is the function given that f of x equals x cube minus x square plus 1? So f of 1, what is f of 1? 1 cube minus 1 square plus 1. That is also 1. Both of the answers are same. That means limit x approaching to 1, x cube minus x square plus 1 equals nothing but f of 1. So limit x approaching to a f of x is equal to f of a. That means whenever we have a polynomial function, finding the limit of that particular polynomial function is equal to the direct substitution of the value. Direct substitution of the value. Is it clear? Let's take another example. Here limit x approaching to 3, x into x plus 1, that is equal to x approaching to 3. So 3 into 3 plus 1, 3 into 4, that is equal to 12. F of x equals x into x plus 1. Then f of 3 equals 3 into 3 plus 1, that is equal to 12. Both the answers are same. Whenever we have a polynomial function, then we can say that limit x approaching to a f of x equal to f of a. We know that for the polynomial function, finding the limit and direct substitution of the value both are equal. Finding the limit and direct substitution of the value both are equal. This is only true for polynomial functions. This is only true for polynomial function. Is it clear? Thank you.